started. Hopefully everyone can hear me. First of all, I guess welcome everyone and everyone watching to Marshall Day's Wildlife Conservation Awareness Campaign. I'm here with Dr. Marcus Eriksen. First, I'd like to thank you for being here. We here at Marshall Day and everyone watching really appreciate you joining us for this campaign. For those of you on the phone and using the live stream, not sure if you can see the banner, but if you're interested in helping promote this on social media, it's #StandWithWildlife. Before I start, I just want to share with all of you Dr. Eriksen's bio. He's the co-founder of the Gyres Institute and currently the director of research. He received his PhD in science education from the University of Southern California in 2003. Months before embarking on a 2,000-mile, 5-month journey down the Mississippi River on a homemade raft, his experience on the river led to a career studying the ecological impacts of plastic marine pollution, which has included expeditions sailing 35,000 miles through all 5 subtropical gyres to discover new garbage patches of plastic pollution in the southern hemisphere. Still rafting, his most recent adventure sent him and a colleague across the Pacific Ocean from California to Hawaii on Junk, which is the name for a homemade raft floating on 15,000 plastic bottles with a Cessna airplane fuselage as the cabin. The journey, which was 2,600 miles, took 88 days, brought attention to the work of the Gyres Institute, the organization he co-founded with his wife Anna in 2009. The goal of the Gyres Institute is to drive marine conservation through continued research, education, and action, studying and lecturing about the plague of plastic waste in our watersheds and in the sea. His first book, entitled My River Home, chronicled his Mississippi River experience, paralleled with his tour as a Marine in the '91 Gulf War. The experience of war, sailing across the gyres with diverse crews, and long rafting voyages have led to a strong conservation ethic worth fighting for. He joins us today to talk about ocean plastics and their devastating effect on wildlife. And we'll take questions at the end from the audience when the talk is over. Marcus, over to you.
Good afternoon, good morning, wherever you are. I know some of you on the West Coast, where I just left last night. Took a red eye with my 2.5-year-old little daughter. So it's a good thing that I had a few cups of coffee just recently. Okay, I want to run through a bunch of slides and tell you about this issue of plastic pollution. I know you've all, I'm sure, heard of the gyres, the garbage patches in the gyres, and most recently some of the advocacy efforts about plastic bags, styrofoam, and most recently now microbeads, little small plastic beads and face scrubs. So I'll talk about the research that we do and some of the advocacy work, but focus on really what the latest science is. So you and your company can have some of these tools in your back pocket when you work with your clients and deal with some waste issues and questions about where our trash goes. So let me jump ahead. Next slide. Whoops. Okay, a bit about me and my background. I grew up in Louisiana, in South Louisiana, catching snakes and alligators. That picture you see there was in 1984 on my t-shirt. I had a homemade pond with 1 alligator, about 11 snakes, and 96 turtles in this pond as big as this table, pretty much. And it was a valuable lesson because I learned what not to do with wildlife. That animals in captivity, need a lot of care, and they're better, kept in their natural their habitat. So after I came back from school, a few days into the weeks, I realized these animals were not healthy, so I returned them all back to the wild and didn't catch any more, and enjoyed going out into the wild. One wild space I didn't expect was the first Gulf War, and that picture is me with an Egyptian spiny-tailed lizard. And that's where I really began to think about, where is the world headed and what is my role in it. And during the Gulf War, I made a promise to another Marine sitting in the foxhole that if we survived the Gulf War, we'd build a raft and, like Tom Sawyer, Huck Finn, have an adventure down the Mississippi. I couldn't find him, but in 2003, I built my raft and spent 5 months looking at the river and watching trash float by. I mean, I could almost always see a bag or a bottle or a bucket or a milk crate going by. And what I thought a lot about, since then and till now is what is the good fight? And for me, what I understand, what's on the horizon, now being a father, there are risks of resource scarcity to deal with, overpopulation and an abundance of waste, an explosion of waste, climate change, and the loss of biodiversity. So those things together is what I call the good fight. I focus mostly on plastic pollution. My little niche is to look at what is the impact of plastic trash and the abundance of plastic trash in the marine environment. And I think of where it started. Well, where it ends up is here. And this is where those things, where climate change and loss of habitat, loss of biodiversity, resource scarcity, all come to play, an abundance of waste. I took this photo just 1 year ago in India, and I'd crossed this bridge, heading to the Himalayas. I looked down the river, and I'd photographed the trash, figured I'd come back. When I came back, looked up the river, and I noticed there are people living there, living under the bridge. And these kids you see in the center of the photograph are using plastic trash to build dams to play in untreated raw sewage. And it really made me think about, what is the right fight? I mean, what is going to happen 20, 30 years down the line? What can we do now to mitigate some of the problems that are very much on our horizon? Now, if you look at this photograph, you see all those bales in the foreground. That's the stuff that these communities are recycling. That's the stuff that has value to the poorest of the poor in India. If they don't pick up the trash there, it is going to the Ganga and out to the Bay of Bengal. That is the last stop for trash. And that's where, two things can happen here. Either improve waste management and simultaneously improve design. If you design for recovery, you would not see that kind of trash there or pretty much anywhere else in the world, I'm convinced. Design matters as well as waste management. But how we got started is here. If you look back at the post-World War II, American culture, we embrace this idea of throwaway living. And post-World War II in the U.S., the war machine, that production shifted to domestic production. Every family wanted a washing machine, a two-car garage. They wanted nylon stockings. They embraced the throwaway culture, TV dinners, the hula hoop. Everyone wanted this stuff. So by the mid-'70s, you see all the single-use throwaway packaging is now abundant everywhere in shops across the United States. Styrofoam cups and plastic bags. The plastic water bottle came into being, mid-'70s. So by the late '70s, '80s, it was just everywhere. And the abundance of trash we were seeing across our streets was greater than ever before. Now, some of the early ads, I find this interesting, just for some comic relief. When plastics first hit the domestic market, there were some really interesting applications of plastic. And we'll talk about good design. This, I would say, is not on the good design side of the scale, nor is that. And that grosses you out. Try 3. But if you look at the production of plastics, it began in the 1950s, and the most recent estimate, now in 2013, is 299 million tons. So we've now, in the last 65 years, we've reached from 0 to almost 300 million tons of plastic, new plastic, produced each year. So these issues are very clear, and very present, and they're going to be with us in the future. So how to deal with those, improve waste management, improve design, are where I think solutions should focus. Because this is where we are now. And this is not an atypical one little photo. We're seeing this around the world, especially in countries that do not have adequate waste management. But they're importing the single-use throwaway packaging and product design. And they have no recourse what to do with that material. So what I do, our organization, we saw a gap in the data. We had just discovered this Great Pacific Garbage Patch. Captain Charles Moore, a dear friend of mine, we worked together for a few years. He had sailed back in '99 from Hawaii back to Los Angeles and found abundant microplastics. And that became the Great Pacific Garbage Patch. And working with him, he was going to stay in the Pacific. And we knew from some of our modeling that other subtropical gyres might accumulate trash. So the Gyres Institute was born with the intention to sail to all 5 subtropical gyres and document the global abundance of waste. Our first expedition, though, was not these 5 gyres. It was a stunt that we did. Those are the 5 gyres. Was to build this. First, is to show the public there was not just misinformation in the sciences. In the public's eye, there were mountains of trash in the oceans. And having been there a couple times already, there are no mountains. The big trash doesn't exist in the gyres. You might find some fishing gear because it's so well designed for that environment. But for example, plastic bags, I almost never find plastic bags in the gyres. They fragment and shred so quickly. So our first expedition was a stunt. We put a Cessna airplane on top of 15,000 plastic bottles with no motor, no chase boat, and we drifted somewhat aimlessly, for 88 days to get to Hawaii. And I had bet on like 4 weeks to get there, maybe 6 if we're unlucky. 13 weeks later, we got to Waikiki, but in the middle, ran out of food, and I caught this fish. Can we show the video real quick? So this fish, I watched this fish being born like day 1. There were 300 fish, and after 2 months, they had winnowed down to maybe 8 fish as they were eating everything around them. I watched them dart in front of my raft and forage on the sea surface. And when I got hungry, they looked pretty good, so I fished one out and opened its gut, and that's what I saw. I don't know if you're going to hear sound or not. No sound? Okay. So good. We're narrating. So yeah, in the middle of nowhere, this is halfway between, California and Hawaii, that we're finding impacts of microplastics on the marine environment, on fisheries. And that fish species is one that you'll find in restaurants and fish markets around the world. So that video, that photograph, is perhaps the most used photograph from that expedition that we did. Ended up in Waikiki, finished this trip, then began our research expeditions. And what we do, our model is to charter a vessel, find one that has a lot of seats on board, and then sell those seats to pay the charter. And it's worked now on 16 expeditions. And our equipment is very simple. We use what's called a manta trawl. This is a 60 centimeter wide box with a fine mesh 1/3 millimeter net. And we drag it behind the boat on the side of the vessel out of the ship's wake for 4 to 5 miles at a time, and that gives us one sample. Very, very simple descriptive data. How many plastic particles in different sizes, the weight and count, the color, and what is living on those fragments. Very simple descriptive data, but it gives us a way to use that data to populate ocean models to get an idea of the distribution and the abundance, regionally and globally. So, first expedition, North Atlantic. This is where I learned not to sail the North Atlantic in January. You can see a big gap in those data points. That was what we call the hurricane gap, where we had about a 900-mile diameter where 2 low-pressure systems came together, sustained 40-knot winds for about 4 days, and won't do that again. But we did sample the North Atlantic, and we found what was very similar to the North Pacific, this abundant microplastics. We found, some fishing gear, again, that's designed for the ocean, but a lot of microplastic particles. Then we got invited to the Indian Ocean by a ship called the Stad Amsterdam. They just called us out of the blue and said, you want to come sail from Perth, Australia to Mauritius to do the same thing, look for microplastics, and found the same thing. And you will find occasionally, a few pieces here and there, larger pieces that are in the process of fragmenting. In the South Atlantic, it's our best data set, where we crossed the South Atlantic 3 times, from Rio to Cape Town, Namibia to Uruguay, and then back to Rio to Ascension Island. And again, the same thing, abundant microplastics. So we're finding these accumulation zones of this plastic confetti. The South Pacific, same thing. We sailed to Easter Island and Pitcairn, same abundant microplastics. And then these accumulation zones they sort of gather in the center of the subtropical gyre. Now what a gyre is simply a wind-driven system of rotating currents. It's driven by the Coriolis effect that pulls the atmosphere as the Earth is spinning, and that drives surface winds that moves the ocean surface. In the northern hemisphere, they go clockwise. Southern hemisphere, they're counterclockwise. In the center of these circular currents are very stable high pressure systems where there's less wind, less current, and the water's kind of quiet. As plastic gets there, the plastic is moving around, waves are crushing it as sunlight makes it brittle, animals are colonizing it, they're foraging on it, it's very quickly fragmenting into microplastics. North Pacific, the same thing. We went back there about 4 or 5 times, about 5 times we've gone there. This is one sample we collected just north of Oahu, most recently, about 500 miles north of Oahu, and we call this our gorilla trawl. Can you see the gorilla? Yeah. So this toothbrush. You know, what's interesting is of the objects you recognize here, there's that white large piece is a piece of a bucket, the toothbrush, the spray nozzle, the pen caps, that toy gorilla. They're very thick polyethylene or polypropylene fragments. Plastic film, plastic foam, it really shreds into small microplastic particles very quickly and disappears from the sea surface, which I'll talk about in a minute. But what's persistent is the thick polyethylene, polypropylene, and fishing gear. So what we did, we looked at all of our data, and I combined my data with 7 other colleagues, a really good data set. Then we had 2 ocean modelers that created a model of where debris might flow based on 3 input scenarios, from densely populated coastlines, rivers, and shipping lanes. And so the model says, okay, if plastic comes in from those 3 areas, where is it going to based on all the current modeling data? And then using all of my data, my colleagues' data, can we populate that model? And we did that, and by doing that, we could extrapolate what was the regional density and the count. And this we published about 5 months ago in the journal PLOS ONE, and it really took the media by storm. This is the first estimate, the total estimate of plastic trash of all sizes and all oceans and all types that's drifting on the ocean surface. And it's not counting what's subsurface on the sea floor or still wash ashore on beaches and islands.
Can you say that loud for the people who are just listening? There are people who are just on audio.
Oh, they just came on?
No, there are people who are only listening through telephone.
Okay. Which I repeat? Which part?
Just the number, because
Oh.
it's extraordinary.
Okay. Oh, I apologize. So yeah, so the weight, the global weight is 269,000 metric tons from 5.25 trillion particles. And just a side note, this is less than 0.01% of the global 1 year's production of plastics worldwide. So even though it's a big number, it's a tiny fraction of what we make. So a lot of it is staying on land, is being picked by waste pickers, is being burned or buried. What's at sea, what's interesting is that what's on the surface is a lot less than what we know is going in. Well, first, to give you an idea of what that 269,000 metric tons look like, if you could stack 2-liter bottles and stack them to the moon and back twice, that's the weight of plastic trash floating in the world's oceans. Or line up plastic straws around the Earth's equator 425 times. That's 269,000 metric tons. So let me jump ahead a bit. Okay, when we divided all of our debris by category, we found that, again, fishing gear was the predominant type of debris. By weight, 58%. If you had fishing line and nets, it's close to 70% of that weight is fishing gear, things designed to persist on the ocean surface. And the rest are the other plastics that are shredding very fast. Look at the count. Well, if you look at the count in weight, where is it most abundant? In the North Pacific. So the North Pacific, I think it's because of the contribution of trash from the entire Pacific Rim, makes the North Pacific gyre the most trashed. And again, most of that is fishing gear. And a lot of that is coming from aquaculture and maritime activities in Southeast Asia. One very interesting side note from our data, we divide our data into 4 size categories. We have the things that are like as big as a beach ball or bigger. That's that bottom right corner. And you don't see much there. Look at the bottom left corner. That's the stuff as big as a water bottle down to the size of a grain of rice or a lentil. There's a little more of that size. But look at the top. The top right is the rice grain size fragments. The top left are the salt and pepper size fragments. There's a whole lot more of the rice size fragments than the salt and pepper size fragments. What's happening is the debris on the ocean surface in the gyres, that's not the final resting place for plastics. It's not forming these accumulation zones that are very static and trash stays there. The trash, what we're finding is in the gyres, it shreds, and those particles, they're colonized by organisms that make them heavy. They're consumed by lots of organisms, and they become, once they become very, very small, they react more to the density of water, the surface tension of water, and microcurrents rather than their material buoyancy. So a small particle doesn't take much ocean current to drive it downward beneath where my naturally capturing particles. So the way we look at the ocean plastics now, and I should tell you that this field of marine science is changing so fast. There have been more papers published in the last 2 years than the previous 4 decades, beginning in 1972 with the North Atlantic plastics paper that was published. There's so much we know now. So how we look at the ocean plastics is that places that have poor waste management, that aren't managing very poorly designed plastics, that are losing plastic waste, they're the generators, especially closed seas and gulfs, like the Bay of Bengal and the Mediterranean, which have not just a constant input, but also they have closed systems. The South China Sea, the Gulf of Mexico a little bit, but once the trash enters the ocean, it very quickly begins to shred. And there are all kinds of ocean mechanics at play that are reducing large plastics, macroplastics, into microplastics. And then what happens, those then are sinking, the smallest particles are sinking, they're moving laterally, they're moving vertically, and they're being distributed globally around the world. I sailed last summer to Iceland, and just last month to Antarctica, and I can tell you we find microplastics everywhere. So this is what 5.25 trillion particles look like. Now this is not the garbage patches you may have envisioned in the past. The way we should really look at plastic today is very much like smog. The way we saw that particulate of carbon over our cities in the 1970s, over Los Angeles and New York, and today over Beijing and Delhi, that is air pollution is a fine particulate of carbon moved by atmospheric currents and slowly settling to the ground. In the oceans, it's very similar. It is an abundant, small microplastic hydrocarbons that are distributed by ocean currents and slowly settling to the sea floor. It is, you can visualize it the same way, and it behaves in very much the same way. And that's how we should look at it. And that's going to drive sort of how we think about solving the problem. Back in the 70s, there were people that said, with air pollution, put a vacuum cleaner on top of a skyscraper. And everyone looked up and said, that's ridiculous. You're not going to clean up that with some techno fix. You've got to stop at the source. So we saw improved systems for smokestacks and coal-burning power plants. And we saw improved emissions for cars, emission standards, catalytic converters. And that really did a good job to clear up. I live in Los Angeles, and the skies are relatively, much clearer than they were, 30, 40 years ago. So with plastics, we're going to see the same kind of solution needs to apply to this issue. The problem is that people can't look out to sea and say, oh, it looks like smog. It looks like clouds of plastics on the island. There are very few people that study this issue and are out there looking at it the way we have for the last decade. So what's the impact? Just so you know how we should look at plastics, it's not this benign material in the oceans that just floats around and sinks to the seafloor and gets sequestered there. It has a very insidious life cycle in the oceans. First of all, it's a very resilient material, and the impacts of entanglement and ingestion are very real, and it hurts a lot of wildlife. I used to work at the Audubon Zoo in New Orleans, and this turtle came into us, had walked into a milk jug ring as a hatchling, and couldn't break that plastic corset around its waist, and grew into this that shape. In 1999, I went to Midway Atoll And every dead albatross I saw had plastics pouring out of its stomach. And these are products that have alternate, more benign materials for bottles, for bottle caps, for cigarette lighters or metal lighters. There are ways to have not just the convenience, but the culture of having bottled water, having cigarette lighters, and having fire, having all these things. We can have this and not have the output of waste. Whoops. Let me roll back. No? Okay. On land as well. I just recently, a colleague in Dubai sent me 3 of these masses. They're between 20 and 40 pounds apiece. They were found in the stomachs of camels. So we're finding lots of animals on land are consuming plastics. I know in South Africa they call the plastic bag the national flower because it's just everywhere, stuck in the trees. So when I do my sampling during the day, it looks like this. A nighttime sample looks like this. And if you know much about the marine ecosystem, there is this massive vertical migration of life that comes to the surface. If you've been diving at night in the mid-ocean, you'll know what I'm talking about. The biomass that comes up from the depths to the surface, it's amazing. It's unbelievable. Bioluminescence, when you move your hands on the water and you've got green trails of light coming off your fingertips, and there's the strangest creatures and these myctophid fish, as you see here, darting about with photophores in their bodies. It's an amazing ecosystem. They come to the surface to feed on the buffet of phytoplankton, feeding zooplankton that's right there in the surface layer. Well, we collected 687 small fish in one season, and 35% of these fish had plastics in their guts. From a fish perspective, they don't know the difference. So this photograph, this is fish vision. There are 2 bits of plastic here. Can you see them? So from a fish's point of view, they just gobble what's on the surface. So once again, 35% of the fish that we collected had ingested microplastics. And this again is in the middle of nowhere, the center of the North Pacific subtropical gyre. So what we're finding now is that microplastics, as they get smaller, they're being ingested by filter feeders. From lugworms to zooplankton, even barnacles, jellies, even up to baleen whales are consuming microplastics. So unlike smog in the atmosphere, where there's not much there to ingest in the oceans, you've got abundant life. Imagine if there were trillions of birds flying through smog over LA, could be a horrific issue. In the oceans, you've got that. You've got so many organisms that are consuming, they're just filtering out the seawater, and we're finding plastics in their guts. What's interesting is that there were a couple recent studies of lugworms found that because of changes in the pH, the temperature, and gut surfactants in their intestines, that they can actually desorb some toxins off of plastics and store them in their bodies, and it affects their reproductive success and their overall energy usage. So we're seeing that plastics can impact even organisms as small as these. And when the particles get really small, they can translocate across the gut barrier. We have found microplastics, this is like 15 to 30 microns, inside the bloodstream of mussels, the mussels that you and I might eat in seafood restaurants. Up the food chain as well, as big fish eat little fish, they take whatever they bioaccumulated in their organs and tissues, including microplastics. So it's not just one bird, one whale, one fish, one turtle. It's across the board. We're seeing a growing number of organisms impacted by plastic waste in the ocean. So where's it coming from? I mean, where are the points as you engage your clients in consulting? When you talk about waste management and where the waste comes from, where products might need to be designed, redesigned. Here are some of the sources where we think it's really harming the ocean most directly. One is poor waste management. You've got so many countries worldwide that are importing single-use packaging and products, but have no recourse for the waste. This is a river, actually, in the Philippines where there's more plastic, you can't even see the water surface. Microfibers, and we're all guilty of this, and this is a very difficult one to tackle. Synthetic textiles are shedding microfibers, I mean, up to like 10,000, an estimated 10,000 fibers per wash was one study looked at average, U.S. Household washing of textiles. So these microparticles, they persist. We have found them. There's one paper I just reviewed last week. It's the first evidence of microfibers in game fish in Texas. Another colleague doing the same thing, game fish in the Great Lakes. We're finding microfibers, microplastics in the guts of freshwater species as well as ocean life. Derelict fishing gear. These fishing nets, and I find at least 1 or 2 fishing nets in each expedition, when you haul them out of the water and you shake them like a piñata, all this life falls out. I mean, they are these floating reefs. They are these new, it's this new sort of ecological niche, these floating reefs. But as you shake it, thousands, tens of thousands of fibers fall from these nets, and your hands are covered in fibers. So one lost fishing net, first of all, it doesn't stop fishing, and they can live on for 10, 20 years. They're shedding microfibers by the tens of thousands. Catastrophic events. What's interesting, in the geological record, there is going to be this thin horizon of plastics from our consumption of plastics. But you get these catastrophic events that create these huge pulses of trash. A lot of it sinks near shore, and you'll see that in the geological record for sure. Whereas in the past, you have some turbulence and sediment from tsunamis and hurricanes and the like. Now you've got layers of trash. The Japan tsunami produced well over 20 million tons. Katrina is estimated 118 million tons of trash, all washed out to sea in these single events. They're significant pulses of trash. That's one source. What are the sinks? So once it's all out there, where is it going? Here's what happens. So a plastic bag, bottle, or cup, or a straw, or a stir stick, or a lost fishing gear, it begins to photodegrade. So sunlight can break the polymer chains. It also it causes lots of other plasticizers to leave plastics, making them very brittle. So once that happens, oxidation, you get mechanical degradation next, and that is simply waves just crushing plastics. That's why plastic bags don't survive. Plastic film, plastic foam degrades so fast because the surface area is so much greater than its volume. So photodegradation, mechanical degradation, reduce macro to micro very fast. Biodegradation. We have found, and this is very, very rare, but we have found that some microbes can eat polyethylene. On the surface of laundry bottles, detergent bottles, and some bottle caps, we have found little pits that we think are scoured by microbes. Fragmentation by grazing. This is very significant. And I just submitted a chapter for a book on marine debris, which gives evidence trying to link the bite to the fish dentition. I have one colleague just counted fish bit plastics in Hawaii. He found on the big island of Hawaii, just south of Hilo, on one beach where it's an accumulation of roughly 20 tons a year. 15% has evidence of bite marks on it. And this is from the North Atlantic. Almost every bottle I pick up in the North Atlantic has fish bites on it. And this bite, that triangular bite with the 2 dents above it, I'm pretty sure is a triggerfish. They have this very awkward looking overbite with 2 pointy teeth that grab the plastic, and the bottom teeth just shear off those fragments. And sometimes I often find, just the neck of a bottle, where the rest is just gone, and little bite marks around that. So this fragmentation by grazing is significant. Shoreline deposition. So a lot just washes ashore, goes down rivers, gets washed back up on land, or in the gyres, a lot of the big stuff, if it's not, as it's breaking down, it'll hit an island, and the windward side of almost every island I've been to is awash in mountains of trash. Just recently, I sailed about 6 months ago from Bali to Christmas Island, Australia, and all that trash leaving Indonesia that's flowing west, washing ashore on Christmas Island, on this one beach, maybe 50 feet across, I could have picked up 5,000 flip-flops. And there's plastic bags and cups and bottles, but the abundance of shoes was amazing. We called it flip-flop beach. So deep sea deposition. We are now finding, this is just in the last, about a year and a half ago, this paper came out showing microplastics on the sea floor. So the entire life cycle of plastic is you've got trash leaving land, poorly designed products, poor waste management, out in the sea. It shreds, it accumulates in the gyres, it sinks, and it settles to the sea floor. Much the way, smog in the air is settling in the ocean is the same way. So just to throw in a couple notes about this is where the frontier on the issue is now, looking at ecological and human health impacts of plastics, both as a consumer product. Do those plasticizers go into your body when you drink from a water bottle or a brand new styrofoam cup? Is styrene actually unbonded monomers of styrene in that cup? Like your Dunkin' Donuts coffee cup? Sorry. So this fish that I caught, this rainbow runner, with the microparticles that came out of its body, what we know is that those particles, they absorb lots of toxins. One colleague, Dr. Takata, University of Tokyo, he found that one small plastic pellet, a pre-production plastic pellet, and that's the form plastic takes when it's first made, and that's the way it's distributed worldwide. It can have up to 1 million times higher concentration of these persistent organic pollutants than the ambient seawater. Things like pesticides, DDT, PCBs, and other chemicals just glom onto plastics. They're hydrophobic, but they're oleophilic, and they'll stick to plastics, which makes them little toxic pills. One study that we did with a colleague, Chelsea Rockman, she was collecting fish while I was collecting plastics across the South Atlantic. We're on the same boat together, and we compared notes. And what she found was that as I was finding more flame retardants on the surface of plastics, she was finding more flame retardants in the tissues of pelagic fish. So we do believe the research is showing us that plastic does pollute the food chain that feeds us. So solutions. This is where it gets complicated, because this issue, it has matured after 15 years from, the last 4 decades, you saw a handful of papers. The last 2 years, a lot of publishing work. The issue is now, it's matured in the sense that, the industries that make plastics, that polymerize it, the petrochemical companies, and the companies manufacturing products now have really dug in their heels in what they think solutions are. Whereas the environmental NGOs and lots of scientists have done the same. And now there's enough information that it's really interesting time, because you're seeing a lot of advocacy work being done on bans of products. So I'll go through a few things of where the solutions are. Behavior is one. And this goes back to the 1970s, when the Keep America Beautiful ads. Who remembers the crying Indian ads, the 1970s, where you had this Native American figure that would see a plastic bag, a styrofoam cup, go tumbling across the street or the highway, and he would just shed one tear. And I mean, the tagline in those ads are, people cause pollution, people can solve it. And that was funded by Keep America Beautiful, which was supported by Coca-Cola, and Anheuser-Busch, and PepsiCo. And what they effectively did was capture the language and put the onus of the problem on the consumer. The idea of give a hoot, don't pollute, and don't be a litter bug, those all pointed to the consumer as the problem, and not the design, not the product itself. So you saw no change in the production of plastics, just more money and effort directed towards public awareness and public litter campaigns. Waste management. This has got to improve worldwide. As many of you I know, perhaps you've traveled around the world, you go to India and China and Indonesia, you will see an abundance of plastics. India did not have the single-use throwaway culture until the mid-90s. It just didn't exist. You go there now, and you're seeing a transition happening from the old clay chai cups to purple plastic chai cups, the sachet packets. It's all there in abundance. And the waste, the abundance of waste, because the population is huge. Well, I think where we can really make a dent is in design. there are some designs that just don't need to use plastic. What we know now about the toxicity of plastics, the persistence of plastics, the life cycle of plastics through marine ecosystems, I think that's going to warrant that we really use plastics in much smarter ways. And this single-use throwaway culture that began in the 70s, when we thought it was a benign material, that needs to go to the wayside today. That idea, that culture needs to be phased out. So what I see right now, so when I say this issue has matured, I see this great divide between environmental NGOs and industry. Whereas the industry says just more recycling, more litter campaigns, and recycle your plastics. If you're not, then you're a litter bug, versus design for recovery. If we can close that loop, right now there's still this linear model of extraction to manufacture, production, and then you either burn it, bury it, and you try to recycle it, which is very, very inefficient, unfortunately. To create a circular economy is what we think about when we say design for recovery. If you design for recovery, I guarantee somebody will pick up all the trash. In LA, where I live, you don't find plastic bottles, soda bottles on the ground. They have an inherent value as a post-consumer material. Whereas everything else I see on the ground today, the bags, the bottles, or the bags, the bottle caps, the stir sticks, the coffee cup lids, styrofoam, pieces, those have no post-consumer value. And that's a place where we can have a phase out and room for innovation. Waste diversion versus waste energy. The industry really advocates waste energy. If you burn plastics, you then make room to produce more. What we advocate is waste diversion, and we're seeing that very effectively done in cities like Portland and San Francisco, where San Francisco now is diverting up to 80% of their waste on some waste streams by having curbside recycling, having bins just for compost and organics. So there's very effective ways, and that reduces the need to use taxpayer dollars for waste incineration and all the other environmental issues that go with waste incineration. Phase out the problem to bring in new plastic products. That's what we think needs to happen. Phase out the single-use throwaway culture and bring in the innovative products. Whereas the industry wants to see more waste management, focus on waste management. We think both, design and waste management. And last is producer responsibility versus taxpayer-funded programs. Producer responsibility simply means the onus is now not on the public, but equally on industry to once again create that circular economy versus charging the taxpayer for more recycle programs, more incinerators, and more landfills. So the bridge, how we can address companies, and this is where our organization wants to focus, is work with companies to say, okay, how can you still exist and do well and profit and not pollute? Here's what we think. If companies can embrace the phase-outs and innovation and support the legislation that levels the playing field. For all these products, for example, microbeads and face scrubs, the alternatives are already market tested. Companies like Burt's Bees uses apricot husks already for facial scrubs. So to work with companies to phase out the throwaway culture, bring in the new, we advocate that. The B Corporation model, where you're not beholden 100% to quarterly returns and shareholder demands, where you have a mission statement behind your company. True costs for life cycle assessments. Almost no life cycle assessment I've seen, and these are used heavily when people argue, paper or plastic. They almost never include the impacts on the marine environment. Those costs are hard to quantify, but if we can do that, put some numbers on the cost of plastic waste to the marine environment, and to tourism, and to navigational hazards. All those things count, and they mean dollars. Have that be part of true cost for life cycle assessments will go a long way to helping us to solve the problem. And the last, EPR, producer responsibility, create that circular economy. So I want to show you an example of what I mean, back to facial scrubs. So 2 years ago, we left the gyres and went to the Great Lakes. We collected 21 samples, and in doing so, surprisingly, we found these. For the first time, well, first we were finding just as many microplastics in the Great Lakes as the middle of the ocean. But these were like strange microplastics, perfectly round little spheres, and they matched the little round spheres in facial scrubs. The same color, the same shape, the same texture, same chemical composition as this stuff. We found that one of these tubes can have up to 300,000 microbeads, and these are designed to go on your face, wash down the drain. Many treatment plants can't capture them. So this is low-hanging fruit in terms of bad design. And just in the 2 years since we had this discovery, as of today, we have 22 state bills to ban the use of microbeads in products, and one national bill. And that's one reason why I'm here in Washington to meet with Senators Pallone and Upton about the bill that they've sponsored. What we're doing also, in addition to working with companies, is citizen science. The data that I use for that 5.25 trillion estimate, it's based on about 1,571 data points. 1,500 data points to estimate the entire ocean, it's not enough. We need citizen scientists to get data for us. So we've built new equipment that sailors can use. We have simple protocols for doing beach surveys of microplastics and visual surveys. And we're looking to create, to have an annual update of our model based on an avalanche of citizen science data we intend to collect. And that's where we can maybe use some insight, maybe some assistance and help from you guys, ways to engage the public or engage companies in helping to really monitor this issue, to get an idea of what is out there today and if it's getting better or worse over time. And my last slide, I want to invite you to sail with us. So next month, I'm in the middle right now of planning this massive expedition. We're going to sail June 2nd from Miami to the Bahamas, have an international youth summit in the Bahamas with 160 kids from around the world, and then sail onward from Bahamas to Bermuda, then Bermuda, sail to New York. And I have open seats on leg 3 if you want to sail to New York in style, aboard this tall ship. You're welcome to join me. Just let me know. Stay in touch and come join our ship. That ends my presentation. Thank you all very much.
Thank you. Go ahead. All right, well.
How are we on time, first of all?
Excellent. We have at least 12 minutes for questions. The last thing we're going to do is just wrap up with a quick mention of what Marshall Day is hoping to do with this. The last thing we try to do for these is to say, for the Gyres Institute, Marshall Day is going to make a small contribution to try to help with that. So
thank you.
And thank you for coming.
It goes a long way.
Yeah, so now we can start with questions. I was going to start here and then move to our other virtual locations. And as the first person to ask it, or as the moderator, I guess, I'm going to just decide to ask a question myself. So I was actually curious about so we have this global production curve of plastics, and it seems like a lot of it is going to Asia, Southeast Asia, India, and China. What do you see as options for kind of bending the curve of use of plastics over there? Because we can do some things here to reduce our own plastic use, but what can we personally do to help target that geographic area of the problem?
That's a very interesting point, because I have colleagues in India that want to address that same issue. They see an abundance of plastics and no significant push towards building infrastructure to deal with waste in India. Mm-hmm. And for some of the products, the focus will be phasing out the products. So that's one thing, is to phase out and bring in some alternative that's more environmentally benign. In India, sachet packets and these little chai cups. And there are some innovative materials. There are bioplastics that can replace those. There's one called PHA, polyhydroxyalkanoate, made from bacteria, has a half-life of 18 months in the open ocean. So there are some innovative materials. There are also alternate products. Like in India, they use clay cups forever. There are now some paper composites that can be lighter weight, more durable, that can do the same thing as a plastic, which are made of polystyrene. You can replace those with this paper composite. So there are technological innovations that can be, I think, introduced to these emerging markets. If you think about it, those emerging markets, India, China, Russia, Brazil, they're going to have, in the next 20 years, 1 billion more people in the middle class. And they want that same convenience that we've enjoyed for the last half century. And they're going to get it. What we're finding is that in speaking with my colleagues in India, there is a leap in technology. I think Modi, who's the prime minister there, he is making some cities that he's building from scratch that are 100% solar. So there are some leap in technology. So one thing that we can contribute is to offer those technologies to these emerging markets. That's one thing. Another thing, you talked about the waste being driven in those parts of the world. China just introduced what's called the Green Wall. They do receive lots of our waste. And the Green Wall was established because they were getting like all kinds of waste they didn't want. From biohazard stuff, from hospitals, they were getting unexploded ordnance, who knows where it came from, and other nasty stuff, some hazardous waste as well. So, but China now still takes stuff, they scrutinize kind of materials. I went to one site in India, in Mumbai, the Dharavi slum, where they import lots of plastic waste. And for them the cost benefit is that empty shipper containers are going to China anyway. The film of plastics is cheap, and the cost of labor and the healthcare is really very, very low. So importers can take plastic waste and make low quality plastic pellets for a fraction of the cost it would take to recycle plastics here. So very little stays here and gets recycled. A lot gets exported. But the conditions of recycling there. What I saw in India was there was mountains of trash. I could read, have a nice day, New York, New York, on some of these plastic bags. And you have one line of women who are sorting the plastics into different types. They're biting it saying, that's PVC, that goes over there. The next room, are these giant flywheels that shred the materials. And the next room is where they melt it. Big giant funnels to these red hot cannons that extrude melted plastic like spaghetti. And one guy just cutting off these pellets. And they're filling sacks and sacks of pellets every day. And I had a headache in about 5 minutes. And I learned from one group that works with them that the guys in the melting room, they lose about 20 years of their lifespan working in the melting room for $2 a day. So our export of plastic waste, there's this really unknown to the public, these other effects that I don't think that we would tolerate if there was transparency in that process.
I have a question. You mentioned under health effects, are there impacts on people's health of, are those fish getting into our food supply, and ergo are those contaminants in the plastic that they're eating getting into our food supply, and is there any documentation on that?
That's where the frontier of the science is now. It's very hard to make that link between ocean plastics and of the food chain and then having an impact on human health. But there haven't been any studies showing that plastic is the vector for pollutants to get into the fish that are in fish markets. We do know that in some fish tissues you'll find mercury and you'll find other contaminants, PCBs and other things in fish livers. To say it comes from plastics, that's the vector for that, is hard to say.
Too many variables.
Yes, but to say that plastic is a vector for the bioaccumulation of some toxins, like the one slide I showed of flame retardants, we have shown that. So those pieces, they're slowly becoming, the chain is beginning to form, where we can say that this does in fact. If we use the precautionary principle, we can say, okay, we do need to act. We know enough to act. That's a hard argument for a lot of other entities to swallow.
All right, I don't want to take too many questions here, so I think we can move on to Fredericksburg. If there are any questions down there, I think Erica Wettergreen had at least one. Yes, Erica. How do we? Oh, there
I know you mentioned the sea change expedition, which sounds absolutely amazing. Are there other opportunities for hands-on support by GYRE, such as internships that people can be part of?
We have our first couple of interns arrived this summer in California to work with us. We're going to expand to a bigger office where we'll need interns to help us do some of the sample analysis. One thing I encourage when I get that question is to do citizen science work. It's very easy to walk to your beach, use our protocols, and if you're persistent to go to your beach, once a month, once every 2 months, and just do our our microplastic square meter transect in the same place, 3 or 4 times a year, for a few years, that is extremely valuable data on the trends in accumulation or an improvement in the situation. So we're really looking to focus a lot of the interest into doing citizen science. If you're at sea, visual observations, 1 hour of staring at the ocean surface within 100 meters of your vessel, and pay close attention to what's going by, what's bigger than my net. That's valuable data. If you want to drag a net, we've invented a trawl that has 4 hinges. You pull a pin, and the whole trawl folds to fit in a 16-inch cube for sailors that have limited space. So our citizen science is one great way to engage. But also, we have campaigns. Our microbead campaign, trying to get, at the state level, more and more people interested in stopping the sale of products that contain microbeads, because they flush right to our lakes and rivers. That's one way to engage. So there's lots of things locally you could do to help organization in this movement. But if you want to intern, I'm sure next year we'll have room for more interns. And a bigger boat next year.
Are there any other questions from Fredericksburg? Maybe one more, if there's an option.
There's one in the back.
All right. Yes, you who raised your hand.
Hi, Dr. and thank you for talking to us today. I'm Maria. I'm a student and I'm working with Marshall Day this summer as a researcher. Turn to research oceanic plastics and make a database of all the things that are going on with it. And my question to you is that would that be helpful to you and other scientists who are working on this problem? And if it is helpful, which direction should I go? Should I make it more geared towards scientists or more geared toward the public? As you said, engaging the public is very important. So I just would like to hear your thoughts on it.
Your database. I mean, are you trying to see what's been? It's like a lit review. Or are you getting data on citizen science work? Lots of organizations doing that kind of work. That kind of advocacy that's being done. I mean, there's so many parameters now to this issue. So what's your interest?
I've been working on more of the citizen science
Okay.
work, and also I have been thinking about taking legislation into account as well, what legislation is going on, what citizen science has been going on, what college science, what university science has been going on, and putting it all in one place so everyone can see it and, just reduce redundancy.
That, a clearinghouse for all the above would be very, very useful. So I'd love to see what you come up with. There's one website called Plastic Free Times. It was an attempt to do something like that. It might have a plethora of resources you can harvest just to add to your database. But I'd love to work with you more on that, so please stay in touch.
Right.
Thank
What
you
was that
very much.
Again, plastic what?
Plastic Free Times. And they had a database of who's doing what and where.
So I guess we can move on to Oakland. Any questions from Oakland?
Hi, this is Claire Shipman. So I was wondering, you've spoken several times about the importance of citizen science. Does your organization take a perspective more along the lines of more data is good data, or do you have concerns about the reliability of that sort of data and using it in this study?
That's always an important question with citizen science data. So we keep the protocols very simple. So what I do, again, it's very descriptive data what I do. I use a very fine mesh net, 300 microns, and I divide my data into 4 size classes. There are 2 microplastic size classes below 5 millimeters, and then 2 above. For citizen science, what I'm asking people to do is drag a 1 millimeter net and take all the plastic they find, pick up the particles, because it's hard to visually look at what's less than 1 millimeter. Take 1 millimeter and above and put it onto a piece of graph paper that has 5 millimeter grid. And then whatever particle is inside of a box, that goes on this side, and outside is on this side. If you do it that way, it's so simple, but if it's done well, with some oversight, it can be robust enough for publication. I have one colleague in Chile, he employed 22 schools to survey 200 sites on the entire coast of Chile, of all the beaches. And that just got published in Marine Pollution Bulletin. And it was robust enough with teacher training, a few times, and then he had people go visit their sites and just monitor them, and the data was useful. And they're doing it again annually, as a way to monitor their beaches. So I think it can be done. but there is always that risk of whether it's valid and reliable.
Great, thank you. I guess we can try Oceanside now also.
Sure. So this is Don Chase in Oceanside. I had a question about the point of source sort of emissions that are coming from these larger developing nations, third world countries and whatnot. And I guess the real question is, how do you stop the flow into the ocean? And with that, are the governments taking much action, or is this on their policy agenda? And then, sort of as a follow-up, is this part of the larger global climate change discussion in terms of the plastic lifestyle costs in general? And are you seeing any push from the global discussions down to talking specifically about the usability of plastic as we move forward?
Well, it's a big question. I mean, the issue of plastic pollution and climate change, there hasn't been much discussion of how they overlap. And I just wrote a blog when we went to Antarctica. I went there with Robert Swan. He has a project called 2041, trying to reenact the Antarctic Treaty that's going to be expire in 2041. His focus is climate change. He had long discussions about plastic pollution and climate change. And we both said, it is coming from, it's the same resource, the exploitation of fossil fuels to produce carbon and electricity. So, and those two things produce plastics and electricity, power materials. And the same sort of system of no accountability for the outcome, that linear sort of linear model, is what is causing both sectors to pollute. So I think that's where there's common ground. There is not much more conversation I've seen than that. There's another question you had about the outputs and what countries are doing for outputs of plastic waste. Is that what you said? Okay, so my colleagues in India, that's where I've been working the closest. Modi, the new prime minister, it's on his agenda to clean up the Ganga and the Yamuna rivers of plastic waste and other waste streams going into those rivers. Because of the abundance of plastic trash they see flowing out to sea and washing back up on the beaches in the Bay of Bengal. And his initiatives are to do more capture at the tributaries that go into the rivers. And I haven't seen much in terms of product shift. There's a very big plastic lobby from a company called Reliance in India that pushes back on any attempt to reduce the consumption or production of plastics. But it's more on cleanup, river cleanup, and then catchment at river mouths. There has been a lot of talk about going to developing countries and implementing systems of capture at the end of rivers. There's one good example actually here in Baltimore called there's the big water wheel. It funnels trash to this one water wheel that's water propelled, and then there's like an escalator that pulls trash into a giant hopper. And I talked to the builder of that just a few months ago, and he said that one contraption, that one river in Baltimore, it recovers 150 tons of trash a year. That includes, waterlogged logs and wood debris. But it was really impressive. Other parts of the world, this focus on post-consumer cleanup, cleaning up beaches, cleaning up rivers, and cleaning up the ocean, I think it's not going to be as effective as it's being sold to be. It's really going to take working with companies like Reliance and Johnson & Johnson, Procter & Gamble, and Unilever to get them to really shift that linear model, that idea of a throwaway culture. We have to make the idea of throwing plastic away, even in designing it for throwaway use, has to be as taboo as smoking in public or not wearing your seatbelt. And that's, I think, the shift that a small organization like ours, we can do some research, but to shift that. And I'm actually seeing lots of NGOs in other parts of the world, in Bali, as well as across India and Hong Kong. Small NGOs, grassroots organizations growing, they're doing lots of public awareness about and targeting the biggest polluting plastics, like the straws, the bags, and styrofoam. So, I mean, these efforts, as you mentioned, they are beginning. The talk of climate change and plastic pollution being, on equal par, and small NGOs dealing with their plastic waste in developing countries is growing as well. It's kind of just starting from what I can see.
Okay, thanks. We're over time, so sadly I don't think we'll be able to get to the
We talked about that, we just.
folks on the phone.
If you can hear me, based on the, can you hear me?
You're breaking up.
Okay, here. There's over here.
Can you hear
Okay.
us? We have time for one more question?
Sure, we can do one more question, maybe from somebody on the phone. Not sure. But if there's anyone left with another question
Any more burning questions?
that we can hear? Well, that was
I've never had this big of an online audience, so it's nice to see all of you
I'll
at
throw
one
something
time.
in that's very consumer driven. I'm fascinated by flip-flop beach. Not being a flip-flop person at all. Is there some way to, I mean, those are so ubiquitous. Is there some way to work with the producers? Is there some, public awareness, something that we can do to reduce that huge, I mean, that
A way to
seems to me like
mitigate
a big,
flip-flops?
yeah. Or mitigate them being made from I mean, the whole point of them, as I understand, is so that
Yeah.
they're plastic. I mean, talk about throwaway.
Yeah.
And
It's tough because
nets,
you're up against issues, like I don't want to go to Bali and tell people to stop wearing flip-flops when they can't afford shoes. So there's lots of social issues you got to deal with at the same time. And like the kids in that first slide I showed, the kids in India who are using plastic trash to make dams to play in raw sewage. I can't say now, you recycle. It's not going to resonate. It'd be foolish and insulting for me to do that. So I think to impact the plastic waste issue there, you kind of got to take care of a lot of issues simultaneously. So I think with flip-flops, you have to address other issues. Though there is one company in Bali called Indusol that makes flip-flops from car tires.
Interesting.
Yeah, and they sell them in San Francisco, not in Bali.
All right, well, I think that'll be it. We did a good job at 20 minutes of questions, so hopefully everyone got theirs answered. And thank you everyone for watching and coming, and thank you for being here and helping
You're
us
welcome.
with our
Any more questions, just go to marcus@5gyres.org. It's my email address. Happy to answer any other questions then and talk more about the issue with you. Thank you for having me.
Thank you.
Thank you for what you do.